Hello guys, welcome back to the lecture of time and space complexity in Python. So this lecture you can say is the first lecture when we start the advanced data structures, right? Advanced data structure. So from this point I am starting the advanced data structure, but if you are watching this video for the very first time, you can just check out our entire Python course on bigdatayatra.com and bigdatayatra.com, and you can follow us on Instagram as well on bigdatayatra, right? We are posting daily reels here as well, so it would be good short learning for you if you are following us on Insta, and it will be good morale boost for us as well. Now without wasting time, back to the main topic, time and space complexity. Now, so time and space complexity, correct? Let's understand this. Suppose you have written a program called print hello, right? Simple. You have written one program, this print hello in Python. Now I have my MacBook M4. So I have my MacBook which is M4. So in this, let's say this program runs in 0.0001 millisecond, or for easy understanding purposes I am saying it takes roughly around 2 seconds, right? I am converting this milliseconds to 2 seconds, so don't think it will take 2 seconds to print hello world. No, but for understanding purpose I am writing, okay, 2 seconds. Now if I will run the same program, say suppose in a old Windows laptop where I have very less RAM, very less storage, there it takes 4 seconds, right? Same program, it is taking different time in different machine, okay? So can I say print hello is taking 2 seconds, print hello is taking 4 seconds, print hello is taking, say suppose 1 second in some good MacBook or in some good Windows? Then what is the way with which I can derive the source of truth, right? I need some sort of source of truth, correct? Source of truth, that this print hello, no matter what machine I am running my code on, it takes so and so time. So this is my problem currently. Let me go to the PyCharm and you will yourself see. Say suppose I am opening this, and let's suppose in this I am printing hello world. That's it, right? Let me just remove these two hello worlds I am printing. So here you can see hello world got printed. So how much time it took? It took just milliseconds of time. Now say suppose this is a very small program. Say suppose I'm talking about very vast program. So this system will take some other time, some other system will take some other time. So there has to be a way so that I can say, okay, this program takes this much time, this program takes this much time, okay? So this is where my time complexity comes into the picture. Time complexity comes into the picture, right? You understood the problem first. There has to be a way with which I can say this program or algorithm will take this much time, right? Because different machine will have different time. And also let me just tell you, this time complexity is not equal to time taken. Very, very important. Say suppose my print hello took 2 seconds. Then can I say time complexity of print hello is 2 seconds? No. Time complexity is not equal to time taken. Then what is time complexity? What actually is time complexity? Time complexity is the rate, very, very important. And I have not heard and I have not by heard this definition. You also try to understand the concept. Is the rate at which time taken, it is not time taken, time complexity is not time taken, it is rate at which time taken increases with increase in my input size. You got it, right? Time complexity is the rate at which time taken increases as per the input size. Okay, let's take this with the help of example. Say suppose I have array and I have 5 elements, and say suppose I want to print these 5 elements. I will loop on this array and I will print all the elements one by one, one by one, one by one. So say suppose to print this 5 elements, right? So it took 5 seconds. Now I increase the element in this array. Now it has 10 elements. It has 10 elements. 1, 2 till my last element is 10. Now to print this 10 elements, I am taking now 10 seconds. So now see the rate at which time taking is increasing on the basis of input size. If I have doubled my input size, the time taken has also doubled. So this is my time complexity कि किस रेट से आपका प्रोग्राम या एल्गोरिदम का टाइम जो लग रहा है रन होने में वो बढ़ जाएगा अगर आपने इनपुट साइज बढ़ा दिया. Simple, right? Let's take this with the help of a graph. Let's take this with the help of a graph. Say suppose here I have your input elements, this, and this is my old Windows, and this is my new MacBook. I will be make it very simple. So say suppose time taken here is 1 second, time taken here is 2 seconds, 3 seconds till 10 seconds, and number of input 1, number of input 2, 3, number of elements in this array 4, 5, 6, and so on 10. So if number of element is 1 in the array, it is taking 1 second to print. If number of element is 2, it is taking 2. Number of element is 3, it is taking 3, and so on, right? So I can draw this straight line, and this rate, this you can say angle, or this you can say theta, is the rate at which my time complexity or time taking is increasing on my input size. If my input size is increasing, then my time taking is increasing, and the rate at which it increasing, which is this angle, is nothing but your time complexity. Say suppose in my new MacBook, now to print 2 elements it is taking 1 second. To print 4 elements it is taking 2 seconds. So the rate at which this time taking by my program is increasing on the basis of input size is my time complexity. So obviously time complexity will be less in new machine, time complexity will be more in my old machine. So I hope you have got the gist of it. What is time complexity? It is not equal to the time taken, guys. Not equal to time taken कि भाई 2 घंटे लग गए मेरे प्रोग्राम को तो time complexity 2 घंटे हो गए. नहीं, time complexity is the rate at which time taken increasing. Now how to measure this time complexity? How to measure this time complexity? Very, very important. Let's see how to measure time complexity. To measure time complexity, we have asymptotic notation. Asymptotic notations, very, very important. We don't measure time complexity in seconds. We measure time complexity using asymptotic notations. And what are these asymptotic notation? These are mathematical tool. These are my mathematical tool to calculate the performance of my program. Mathematical tool to calculate performance of my program. Got it? How do we measure time complexity? We measure time complexity using asymptotic notations, and these are mathematical tools. Now there are 3 types of asymptotic notation, right? Or we can say we measure time complexity using 3 asymptotic notation. First is big O notation. Second is theta notation. Third is omega notation. Very, very important interview question. Now big O is nothing but my big O and parenthesis, and what I write in this parenthesis we will discuss. Big theta is my theta and then parenthesis. Big omega is my omega and then parenthesis. And what we write in this parenthesis we'll see shortly. But hope it is clear that we measure time complexity using asymptotic notations, and there are three asymptotic notations, big O, theta and omega. And the most widely used asymptotic notation which you will use in your competitive programming and which you will use in your interview too is your big O notation. Very important. So we will focus more on this. However, I will cover theta and omega as well. Don't worry, we will cover everything. I will cover theta and omega as well. But let's focus on big O notation. Big O notation. Let's focus this. Big O notation. Okay. Now, big O notation is what? Asymptotic notation. That is a mathematical tool used to measure time complexity. Okay. Used to measure my time complexity. So let's see, how do we measure this time complexity? Firstly, this big O notation will give me the worst case time complexity. Worst case time complexity. This big O notation will give me worst case time complexity. Okay, let's see with the help of examples. Okay, say suppose I have written for I in range 0 and let me just write 1 to 6. I am printing BDY, big data yatra. I am printing BDY. This is my program. Now, what all steps involved in this program will be written inside this parenthesis. Will be written inside this parenthesis. Firstly, what all steps are involved? Firstly, I will be initialized. That is, firstly, I will be 1, right? Then my output will be print BDY. This will be checked, right? Then I will be incremented to 2. This will happen for my first iteration. These 3 steps, 1, 2, 3, right? This loop will internally, and what is this for loop? Please check the basics. I have already covered in my course bigdatayatra.com. Then what will happen in the next pass? I is 2, then again BDY will be printed, and then I will be set to 3, right? Then till which point this will run? Till my I is 5. So 5 times, 1, 2, 3, 4, 5. And for every 5 passes, these 3 steps will be printed. So total steps will be 3 into 5, which is 15. I hope you are getting. First I am initializing the I, then I am printing, then I am incrementing. Initializing, printing, incrementing, initializing, printing, incrementing, and this will happen for all the values of I, that is for all the iteration. And here I am having 5 iteration because this 6 is excluded. So my loop will run till 1 to 5. 1, 2, 3, 4, 5. So total steps involved is your 15. So what is the time complexity, guys, here? What is time complexity? It is big O of 15, because 15 passes are involved, or 15 steps are involved in this program, right? So my big time complexity is big O of 15. But here is a catch. This is a very small program. So for us, it is very easy to calculate all the steps involved in it. Say suppose you have a big production code, then to calculate all the steps, will it be possible to you in your interviews? कि भाई कौन कितने steps मैंने लिखे इस program में? No, it won't be possible for you, right? So you have to add some, you can say, generic term inside this big O. Inside this big O, you have to write some generic term, right? Let me just rephrase my code. Okay, so what I can say, for I in range, and I am taking input from the user कि कितना बार मेरा loop चलेगा. For I in range n, then I am printing BDY. Then number of steps will be 3 into n, right? For every step I will do 3 steps, and how many iteration I will do? 3. So iteration is or so time complexity is big O of 3n, which is close to big O of n. So the time complexity of this program is big O of n. So instead of specifying the number of steps, I can generalize it using n or 1 or n square. We'll see it in the upcoming examples, but I hope you have got a gist of it. Now, why I have removed 3 and why I wrote 3 of n as big O of n? Okay, so when I calculate my time complexity, there are few golden rules which we should know. Firstly, whenever you calculate time complexity, guys, calculate it for worst case, which is your big O. Calculate always for the worst case, because we will tell interviewer that this is the worst case. Second, always ignore lower values. And thirdly, always ignore constants. Very, very important rules. Now, what I mean by this, let's see what I mean by this. So say suppose I have a big program. Here you can see I have only 15 step and big O of n. Say suppose I have written one complex program and I have something like this: 10n cube plus 5n square plus 8, something like this, right? And say suppose the value of n is 10 to the power 15, n equal to 10 to the power 15. And what is n? The number of iterations, or you can say the input size. So it will be 10 into 10 ki power 15 and 3 plus 5 into 10 to the power 15 and its value will be 2 plus 8, right? So it will be 10 into 10 ki power 45 plus 5 into 10 ki power 30 plus 8 now, and this will be big O of this. So tell me this, in front of 10 to the power 45, does 8 have any significance? The value of 8 is having any significance? No, right? We are talking about 10 to the power 45. So if I will add 8, what difference it will make? It will not make any difference. That's why we ignore this constants. And also in front of 10 to the power 45, what is the value of this 10 to the power 80? It is just like comparing ant with animal. Ant with elephant, correct? We are comparing ant with elephant, so no value. So we ignore low value, we ignore constants. So we can say here 10 into 10 to the power 45, or we can just simply write O to the 10 to the power 45 or 46, something like this. So that these rules you should keep in mind when you are calculating the time complexity. So I hope it is clear what is time complexity. It is the rate at which my time taken by my program is increasing on the basis of my input size, right? And we saw it with the help of graph. Then how to measure? We measure it with the help of asymptotic notation, mathematical tool to perform to calculate performance of program. Then 3 asymptotic notation: big O, theta, omega. Big O is for the worst case. Big O is for the worst case, and we in the big O we specify the number of steps, or we have generalized it using the n, and we have seen how to do it, right? So yes, then let's see some example of big O only before I jump to theta and omega and space complexity. Let's see some example. Okay, let's see some example now. So let's take a few examples and analyze how big O notation is working, right? Say suppose I have one program for I in range n, and then I have another loop here for j in range n, and then I am writing some piece of code. So what I am doing here, so if someone asks me what is the time complexity of this program, what is the time complexity of this program, so first we will have to understand how this is working internally to derive the time complexity. Okay, let's suppose for every loop of I, j will run n times. This we are clear. Let's say n is 5. For example, in this example, let's say n is 5. So if I is 0, the very first iteration, j will run for 1, for 2, for 3, for 4, for 5. For I is 1, j will run again for 1, 2, 3, 4, 5 for n times. Similarly, I2, it will run for 5 times. So every time it is running 5, 5, 5, 5 times. So for I is 5, then also it will run 5 times, right? So what is happening? What is happening here? And when I say n is 5, so now let's take it is running 5 times, right? It is running 5 times. It is running 5 times. It is running 5 times, right? So for every I, it is running 5, 5, 5, 5, 5, 5 times. So I can say it is running for 5 into 5 times, correct? The j is running 25 times, or this piece of code is running 25 times. Can I say this? Can I say this? Or if I want to generalize it, say suppose if I is n, j will also run for n times. So total how many times this piece of code will run? N into n times. So what will be my worst case complexity of big O notation here? It will be O(n) square. I hope it is clear. I hope it is clear. So inside big O, what we write? The number of steps, and the number of steps is written here. So this piece will run how many times? The number of times j will run, and j will run n into n times, or this piece of code will run n into n times. If for the very first value of I, j will run n times, then again j will run n times, and then again j will run n times, and this will happen till how many times it will happen? It will happen till the value of n. So it is n into n, n square. Let's take another example. Let's take another example. So if I have simply like this, for I in range n, and then I am doing something here, how many times this step will run? Only n times. This we have seen. So this is big O of n. This is clear. Let's take another example. For I in range n, now here there is one catch. I will do for j in range I, and then some piece of code. Here j is not n. Here j is equal to I. For j in range I. So let's see. When I is 0, j will also run for 0 or 1 time, right? J will also run for 0. When I is 1, j will run for 0 and 1, 2 times. 1 here and then here 2 times. When I is 2, j will run for 0, 1, 2, 3 times, correct? In this piece of code, for I in range n, for j in range I, for every value of I it will run. So similarly, when I will be n, it will be, j will be 0, 1, 2 till n minus 1. So can I generalize it by saying it is just sum of n natural numbers, 1 plus 2 plus 3 plus n, which is n plus 1 by 2, n plus 1 by 2, which will be roughly again n square only. So the time complexity of this program is also O(n) square. I hope it is clear. You will have to have the internal knowledge of for loop. Internal knowledge of for loop. Then you will be able to understand how this is working. Okay. So yeah, these are the some example of big O notation and how we calculate. Okay. So now let me cover this theta and omega also. It will be more clear. Theta and omega also. Let me just do theta and omega. What is theta here? We have seen this big O indicates worst case, that is upper bound or worst case. This theta is your average case. This omega is your best case. Let's see all three with the same example. With the same set of example, we'll see all these three. Let's say we have one array 1, 2, 3, 4, 5. Now I need to find one element. Okay, from this, suppose I want to find 5, and 5 is present at the last, right? In this case, it is present at the last. So worst case complexity, what it will be? If 5 is the last element, or the element which we are searching is the last element, so I will have to look at the entire element. First I will look this, 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 and then I will reach at the end, and then I will see, oh, 5 is here. So worst case complexity will be big O of n. That is the number of elements in this array. Clear? What will be the best case now? What will be the best case, which is my omega, lower bound? Best case will be if 5 is the first element of array, right? So I can write best case will be omega of 1. That is, I will only have to look at the one element, first element. Now what will be my average case? Average case will be if my element or 5 is present in somewhere in the middle. 1, 2, 5, 3, 4. This will be my average case. So average case will be what? Best case divided by best case plus worst case divided by 2. So it will be n by 2, close to n only. So I can write theta of n, average case in this case. Hope you have got it. I will have to search how many elements? I will have to search half of the elements which is present in the list in case of average case. So I ignore constants. So n by 2 will be almost roughly around to n only. So theta of n will be my average case. So these are the three asymptotic notation, big O, theta and omega, and we always consider your worst case in every program. We'll consider only this worst case, which is your big O notation. So I hope this makes sense, and we have seen some of the examples as well, how to calculate this. Now we have covered time taken, what is time complexity, how do we measure time complexities, we have seen the graphs, we have seen big O notation, we have seen theta, omega, we have seen programs as well in the time complexity. So before I start space complexity, let me just quickly tell you what all we have covered. We have seen what is time complexity, rate at which time taken changes as per the input size. It is the rate at which time taken changes. It is not equal to time taken. Okay. And then we have seen the various programs and how do we calculate using asymptotic notation. There are three asymptotic notation, big O, theta and omega. Now, let me just cover space complexity as well very quickly. Let me just cover space complexity. Space complexity. It's a very small topic. Now, space complexity. Space complexity is the rate at which space taken by the program changes as per the input size. Time complexity क्या था कि time taken कैसे change हो रहा है input size की वजह से. तो स्पेस कॉम्प्लेक्सिटी क्या है कि भाई कितना स्पेस रिक्वायर्ड है इस प्रोग्राम को रन करने में अगर मैं इनपुट साइज चेंज कर रहा हूं. ओके, सो रेट एट विच स्पेस रिक्वायर्ड बाय प्रोग्राम changes depending upon my input size. Okay, and we represent space complexity using big O notation. Very important. Big O notation. Big O notation is very important. So for space complexity also we use big O notation. Okay, now there is one general formula. Space complexity is equal to auxiliary space plus input size. Very important formula. Very important. Auxiliary space plus input size. Okay, let me just, yeah, space complexity is auxiliary space plus input size. Now what is this auxiliary space, what is this input size? Okay, let me just tell you. Auxiliary space is nothing but the space required by the variables you created in the program, in your program. And input size is nothing but the input given to you in your program. Okay, let's see with the help of example. Auxiliary space plus input size. Suppose you want to add two numbers, a equal to 10, b equal to 10. You want to add this. What you will do? You will write c equal to a plus b, right? And these two are, a and b are input variables, or we can say as input size. And c is what we created. C is what we created to store the result. So this is your auxiliary space. Okay, so here what will be the sum? Space complexity, how many variables we created? It will be order of 1 or big O of 1, and then number of input size was a and b, big O of 2. So space complexity will be equal to big O of 3, which is in general terms I can represent big O of n, where n is the number of input size and the number of auxiliary space, sum of both. Okay, so this is it. And let me take one more example to calculate space complexity. It will be more clear now. But before that, here someone will say, Shivam, why you created C? You can just simply write b equal to a plus b. This will also return the same result. But no, I cannot write it. Why I cannot write it? Because I am changing the input only, but I cannot change input. Imagine you are working in a production environment and you received some input from the user. So will you change the input only? No. You will have to create a new variable and then you will have to store it, even though it requires more space, but you will have to do it because you cannot change the input which you will receive from the user or from the production team or any other team. You cannot change it. So it is okay to leverage some extra space, but not to change the input size unless specified. If interviewer tell you ki you can change, then you can use it, but it is not advisable. Okay, then let's take some other example of space complexity. I am writing a program called as function called as array sum, and this is taking my array and I am creating a sum variable here, and then I am iterating in the array. For I in array, what I will do, I will sum plus equal to I, for sum plus equal to I, and then I am just returning sum. Now what will be the space complexity? First टाइम कॉम्प्लेक्सिटी फाइंड कर लेते हैं. टाइम कॉम्प्लेक्सिटी क्या है? फॉर लूप चल रहा है, पूरा जितना एलिमेंट है उतना, तो टाइम कॉम्प्लेक्सिटी क्या होगा? बिग O ऑफ n. जितना एलिमेंट है उतना बार ये चलेगा. सिंपल सा है, राइट? जितने एलिमेंट्स है वो चलेगा. अब स्पेस कॉम्प्लेक्सिटी क्या है? स्पेस के लिए आई हैव क्रिएटेड दिस सम वेरिएबल, राइट, एंड आई हैव क्रिएटेड दिस आई एज वेल इन माय प्रोग्राम. So these two are my auxiliary space because I have created this inside my program. Sum and I have created this, right? And what is the input size? Input size is nothing but array size, and array size will be n, which I will receive from the user. So auxiliary space complexity will be auxiliary space, which is order of 1, you can say sum and I, plus order of n. So total and total it will be order of n. So space complexity is also order of n in this case, and time complexity is also big O of n. You can say order of n, big O of n. Generally we say big O of n, right? So this is all about space complexity, and it will be more clear when we will solve the next programs. Like we will start with searching and sorting, so it will be more clear there. We'll see how time complexity gets calculated for every search program and sorting program. Yeah, for now I hope it is clear. You can check out our full course at www.bigdatayatra.com, and it's very minimal price. So yeah, we'll see you in the next video. Bye bye.